Hello friends. So in this video I will talk about number of reducers. It is another tool in the kit to tune the performance, and let me explain what is reducers first. As this is not a Hadoop training session, I will just give a very high level overview of reducer. So as part of processing data in MapReduce, you will define certain kind of logic in mappers and certain kinds of logic in reducer. Typically, you will do filtering and transformations in mappers and aggregations, joining large data sets, and um, other activities that are related across multiple records in the same data set, or two different records in two different data sets. In those kinds of scenarios, you will implement in reducer. So first, let me explain in this case what I'm trying to do to explain how playing with number of reducers can tune the performance. Okay, and for that I am taking the example of again cards data. You already know, if you are following my other videos, that we will have. Let me go to my repositories. So this is my GitHub repository, and if you go to my home page and click on repositories, and if you go to data, and if you click on cards, deck of cards is a single deck of cards which have 52 records, and it has the color as the first field, sweet as the second field, and pip as the third field. So I'm using a large deck of this this data set, which is millions of decks or millions of cards in a 2 GB file, and I will be distributing the data based upon the pip. So that is the use case which I'm trying to execute to explain the significance of playing with reducers as part of performance tuning. And for this purpose, as I mentioned to you earlier, I have developed a package, Java-based application called performance tuning, Java-based MapReduce application called performance tuning, and in that I have written a program distribute cards by pip. So yeah, as you might have already familiar with the cards, there are 13 pips, 2, 3, 4, 5, so on up to 10, and then J, Q, K, and Rs. So 9 numeric and 4 alphabetic pips. So there will be 13 pips. So I'm trying to distribute data by pip. So that is the main intention as part of this. So by distributing by pip, I would like to sort my cards based upon the pip. So if you look at the outcome of the program in a while, what you will see is all the cards which have 2 as a pip will be grouped as one data set, and then all 3s will be grouped, and then all 4s will be grouped, so on and so forth. So that is the behavior of this program. So it is kind of distributing by pip, or grouping by pip. All the cards of same pip will be grouped to one file. So I have already compiled this program, and I have already kicked off this program with reducers as 1. So it is using only one reducer. You can go through your resource manager UI and go to that job, and you can see how the job is running. So this job is running with only one pip, sorry, one reducer, because I have defined at runtime while submitting the job to use only one reducer. So I am enforcing it to use only one reducer, and actually it is done now. And it took almost uh, uh, 158 to 1313, so almost 11 minutes it took. to uh, to uh, to group this data. So we can actually see the results. ls user hd user, and the output path I have given is this one. So what I can do is Hadoop fsls, as I have given only one reducer, it has created only one file. So what I can do is I can do tail to show you the behavior of the data. Sorry, I have to give the file name. Part R. So if you see, this have all the queues together, and the original data set is not like this. If you want, we can actually do the tail on large deck as well, because that is the input we have provided. So this is all scattered, but the outcome is grouped based upon the pip. So before running uh, next job with uh, higher number of uh, reducers, let me copy the outcome of the first run with only one reducer, and now I will run with 13 reducers. So again, the syntax is Hadoop jar and jar file name, and then if it is not a runnable jar, you have to give the class name with the package name. So demo cards drivers is a package name, and distribute cards by pip is the class name, and then minus d uh, is a predefined option. We can say it has predefined options, and you can use minus d to set different parameters at runtime. So in this case, we are trying to tweak this, and I want to give it as 13. I will explain the logic while it is running, and then we will come back and revisit the results. Okay, and then run this. Okay, so it will take a while to run, and I will explain uh, why I gave it as 13. So as I mentioned to you earlier, this one, which is around 2 GB file, I have produced by so if you take a single deck of cards, it has 52 cards, and for each pip there will be 4 cards. So there will be 4 twos, 4 threes, 4 fours, so on up to 4 yes. So if you think about it, the pips are skewed normally. So there is no skew actually. The distribution of cards in a single deck of cards based upon pip or color or suite, anything, is uniform. That means all the pips are equal in number. So I have used the same deck of cards to generate a large deck. So the number of records for each pip in even the large deck uh, for a given pip is same. So there is no skew in the data set, and as there will be equal number of twos, equal number of threes, equal number of fours in the data set, I want to use 13 as reducers, so that each pip will go to one reducer, and we are actually grouping all the cards for that pip. So each reducer will deal with one pip and store and process the data accordingly. So that is the reason why I have used 13 as the reducers, which is equal to 13 number of pips. Okay, and before getting into details about issues that can rise because of the decisions we made on the reducers, I would like to just show you the code. So I'm in distribute cards by pip, and if you see the reducer, I'm doing nothing. I'm just getting all the cards from mapper, grouping by pip. So pip is the key, output key out of my mapper, and all the keys associated with that pip, all the values associated with pip will be translated into a list when it comes to array. And so automatically when the cards comes to reducer, it will be already grouped by pip irrespective of number of reducers you use. So in this case, as the number of records in each pip is equal, 13 is the ideal number of reducers. So there will be 13 reducers which will be processing the data, and which will eventually group by pip from all the decks we have in the 2 GB file. So now we will talk about side effects of this. If you think about a real world scenario, for example, if you are talking about a major retail store in US, which have franchises in all the states in US, and if you want to compute the sales or top performing store in each of the state, what happens is if you use only one reducer, and if you want to compute top performing store in each of the states, and then that reducer has to sort the data, and then you have to get the means you, as part of your MapReduce job, you have to sort the data, and you have to give the top performing store in each of the city. Or if you want to just see top performer to low performer stores in descending order, you have to come up with that application mapper and reducer, or shuffle and sort, whatever way you write your MapReduce application, you need to take care of this. Okay, now in that scenario where you want to get top performers to low performer in each of the states, in US for a major retail store, you can go with 51 reducers. But the drawback is, if you use 51 reducers, and the reducer for California, reducer for the reducer which process data for New York, the reducer which process data for Illinois, will run a lot longer than the reducer which process data for Montana, North Dakota, South Dakota, all the small states. So the right term for that scenario is skew. So few reducers will be significantly skewed and it will take longer. And the thumb rule for best performance MapReduce applications is that all the reducers should be completed in equal amount of time. Means if there is a if there is a if there is a skew and one of the reducer has to process 50% of the data, then you should only use two reducers. So that is the thumb rule you should follow. If the longest running reducer is processing 25% of the data, then you should use at max 4 reducers, and data should be distributed in such way that all the 4 reducers complete around the same time. If if the top time taking reducer is processing 10% of data, then you should come up with 10 reducers. So in our case, when we talk about states in US, you need to design your MapReduce application in such a way that data is not heavily skewed, and then you have to come up with the number of reducers. In some cases, using probably 10 reducers might work, but the drawback is if one of the reducer get all the large states, then all the 9 reducers will be completed very fast, and that one reducer which is processing data for all the large states will take forever, and it is not a good design. In that case, you can you have to write a custom partitioner in conjunction with number of reducers. I do not want to get into that at this time, but I will cover other use cases where you can address this without writing a custom partitioner. The other use cases are, for example, if you want to generate a yearly report of a major retail store in US. If it is yearly report, and if you want to generate report for 10 years, you can directly set 10 number of reducers, because the data will not be significantly skewed between the years. At the same time, if you want to generate report on monthly basis, typically Thanksgiving and other holiday seasons will have higher number of sales, higher percentage of sales. Depending upon that, you have to come up with number of reducers instead of using 12 blindly. Again, if you use 12, if you want to generate a report, monthly report, and then a few of the reducers will be doing a lot more work, and the execution time of your MapReduce application will will impact due to that. So you have to keep all these things in mind to determine the number of reducers, and it can significantly improve the performance if you come up with optimal number of reducers. At times you can just play with the number of reducers as I'm doing now. At other times you have to use custom partitioners in conjunction with number of reducers to get the optimal performance. I'm not going to cover custom partitioners in this class because it requires development stuff, and I don't want to focus development in this case. But if you are familiar with MapReduce, and if you are familiar with writing custom partitioners, you have to correlate custom partitioners and number of reducers to come up with the optimal number of reducers for your MapReduce application. So this job is done, and let me first copy this to here. And we counted in the beginning that the previous run took 13 minutes, and this one took 7:16 to 7:23, so it took around only 7 minutes, so it's almost it completed at 50% of time. And now let us validate the data. So we have ran Hadoop FSLS command. This is the, sorry, not tail. So if this is the output of the previous run, there is only one file. Now if you see for the one with 13 reducers, there are 13, there are actually 10 files, because the hash value is same for two of the cards. So that is the reason why here in this case these three reducers are double in size compared to others, because the hash value is same for two pips. So if you understand how the reducers works, it uses the default partitioner, which is hash partitioner, and for all the keys that are emitted out of the mapper, it uses it computes hash value, and then it applies mod based upon the number of reducers, which is 13 in this case. So there is no hash, there is no records, there is no values in pips, which gives the remainder 0 when the hash value of the pip is divided by 13. Similarly, there is nothing which gives remainder 11. There is nothing which gives remainder 12. So that's why it is a little bit skewed. So this is what I'm talking about. There is a skew in this, but we can address by writing custom partitioner, which I will not be covering in this case. Okay. So and now let me validate by doing tail. First, let me tail on the first output of the first program. So this is the output of the first program with one reducer, and you can see all the values are grouped by pip, which is q in this case. And now let me Hadoop fs tail, and this I am tailing on the output of the second MapReduce job, and in this case it is also grouped by J. And now we will evaluate the results. Okay, if you see this again, file system counters, there is not a significant difference, but now if you see the job counters, the map tasks are same, but the reduce tasks are 13 in this case. And even though uh, the time total time spent by mappers is almost same, in this case total time spent by reducers is less in the first run than the second run. The reason is we are using 13 reducers, whereas here we are using only one reducer. So the execution time of this MapReduce application is longer for the first run than the second run, but the resources it have used is lesser. So again, you need to do trial and error and come up with optimal number. Does that mean that the second run did not run effectively? That is not the case, because we have enough resources on our cluster to leverage, and we increase the number of reducers, and we have completed the job quicker. So in this case, the execution time is significantly lesser compared to the first run. So even though it is using more resources because we are using more reducers, if the execution time is important for your application, you should consider increasing the number of reducers. And again, do not forget always to keep in mind the custom partitioners when you are planning for your reducers. They both are closely related, and you should combine them to come up with efficient MapReduce program. That being said, that is it for today about playing with reducers. Oh, I'm sorry. Before closing the session, I would like to explain how you can specify a number of reducers in multiple ways. We have already seen as part of the Hadoop jar command, you can use -d parameter, and you can specify number of reducers. And the other way is you can actually in your program, and there is a method called setNum reduce tasks. It is part of job class, and you can use this method, and you can increase the number of reducers. And also you can use the configuration object, like we have seen in the in the card count program last time. We use this one to conf.set method to actually set to higher split size. We can use similar logic, similar conf.set method even in this program to use higher number of reducers, but they already provide a handy function as part of the job class, so you can use this as well. Now when it comes to Hive, you can launch your Hive, and then you can just do set map reduce dot job dot reduces equal to 13, and it will use 13 reducers if you run similar queries as part of the Hive. But one more thing you need to remember about Hive is by default the number of reducers is computed by Hive engine based upon the size of the file, and you will see significant improvement in performance in Hive queries by overriding that. By default this value is -1, which means the Hive query engine or Hive engine will determine the number of reducers based upon the size of the input. If you run any Hive query, you will come to know immediately when it logs the information, it will say the number of reducers are determined by a Hive. But you can override it, and you can enforce to use the number of reducers because Hive does not have an idea about the data. It typically determines incorrect number of reducers, and you are the one who have to set it to appropriate value so that it uses optimal number of reducers. So that is it for this for number of reducers. Similar concepts can be applicable in other Hadoop ecosystem tools, which uses MapReduce as the framework, like Pig, Scoop, etc. But I am only covering high-end MapReduce Java programs to explain the tuning opportunities. Thank you.